Hello and welcome to this presentation of an experimental semantic search in multilingual loanword lexicography. The eLex paper and this talk are joint work of my colleague Tanja too and myself. We will both be at your disposal in the eLex session. Let's start by looking at the resource we are dealing with. The LEHNWORTPORTAL DEUTSCH is a freely accessible platform for resources on German loanwords and other languages, developed and hosted at our institution, the Leibniz Institute for the German Language. For the time being, only a small number of dictionaries is available. Here you can see an entry in the Dictionary of German Loanwords in Polish. Waltz has been borrowed from the German word Walzer, a dance which has also found its way into English as waltz. There are interesting cross-resource search options in the LEHNWORTPORTAL, but there is no semantic or onomasiological access beyond a trivial search for substrings in the word sense definitions. Just by accident, searching for music indeed does the trick for waltz. Specifically for the dictionary on Polish, the word senses of loanwords are assigned to semantic fields, roughly according to the taxonomy in the World Loanword database. You would find lexical material relating to music and dance in the field feelings and values. So, even though this taxonomy was never meant for the purpose of onomasiological access, our example already demonstrates that any such thesaurus-like structure forces the user to reverse engineer the lexicographical practice used to assign senses to domains or fields. And you have that trade-off between granularity of options and ease of use. But all is not lost in loanword land. A thoroughly redesigned LEHNWORTPORTAL will be online in 2022 with much larger coverage of languages and new search technology. The new portal comes with a new database backend that stores lexical units, senses, and dictionary entries as nodes in a graph, that is, as interlinked entities in a cross-dictionary network. But how do you find the waltz here in red in this haystack? In the revised portal, advanced queries can literally be clicked together with a builder. Find words, specifically German nouns, whose meaning is strongly related to that of the German word for rhythm, whose meaning is also related to that of the German word for dance, such that the words are borrowed into at least one of the languages, Polish or Ukrainian. Here the dreamy part is, of course, the prospect of just selecting from a huge list of German words those that are supposed to be semantically related to the word in question. Note that the query shown here returns pairs of a German etymon and a loanword belonging to it, such as, well, Walzer and Polish Waltz. The question is, of course, how we can express semantic relatedness between search terms and word senses of lexical units in the LEHNWORTPORTAL in a sufficiently general way. Our experimental answer is word embeddings. As you might know, word embeddings represent the distribution of words in text, and thus indirectly its meaning, by vectors, that is, long lists of numbers. So far, we have been experimenting with a large set of pre-trained multilingual vectors called ConceptNet, currently featuring almost 80 languages and 600,000 words for German alone. We could easily exchange the set later on if we wish to. In our case, training embeddings on dictionary definitions, such as the ones present in the LEHNWORTPORTAL, would be next to impossible. A picture is worth 1,000 words, so here's the mundane example of German Kartoffelsalat, that is, potato salad. ConceptNet uses 300 numbers between -1 and +1 for each word. Now compare the blue profile of Kartoffelsalat to the reddish contour of the embedding vector of the hyponym Speise, meaning dish. The two numeric profiles look a lot similar. In contrast, the contour of the word Tier, meaning animal, behaves rather different from potato salad, indicating that the two words do not occur in similar contexts very often. Visual inspection will only get you so far. A common measure of the relatedness of vectors is their cosine similarity, obtained simply by pairwise multiplication of the 300 vector components and then summing everything up. Now you actually have a numeric quantity that somehow measures semantic relatedness. Potato salad is close to dish with a similarity of 0.63. The best for completely identical words would be 1.0, while animal is a different beast altogether with almost zero similarity. Now that we have an operational procedure to measure semantic relatedness, how do we put it to use in our graph database? As we said before, all lexical units and all word senses of lexical units are represented as nodes in the graph database. Here we are looking at German Kapelle, which is polysemous, meaning either a small chapel or a small orchestra or band. Each word sense is assigned at least one word from the huge set of available ConceptNet words as a semantically related descriptor word, indicating its semantics. This nicely defaults to the word itself, and indeed there is a ConceptNet vector for the word Kapelle. But the main issue with word embeddings is exactly that they can't account for polysemy. So in this case, manual post-editing is required, which finally brings us to the main subject of this year's eLex conference. In our case, a human annotator could assign at least a second disambiguating descriptor word from ConceptNet, such as the German word for orchestra and church building, respectively. Typically, disambiguating descriptor words would be near synonyms, close hyponyms, co-hyponyms, or otherwise closely related words. So, descriptor words can play different roles. Each descriptor word gets a numeric weight depending on its role. The scheme for mapping roles to weights can be changed any time to improve the quality of search results. By simply calculating the weighted sum of its descriptor word vectors, each word sense in the LEHNWORTPORTAL finally gets a word embedding vector that characterizes its semantics. For end users, the 10 or 20,000 most frequent lemma-like ConceptNet words are selected as possible search keys. As we saw earlier, users may input these keys with the help of autocomplete functionality. For each word sense and each search key, we compute their cosine similarity. If it is significantly above 0 for a given pair, then the word sense and the search key get connected by an edge in the database. The cosine similarity, stored in the edge as a pre-computed property, then allows very fast retrieval of word senses from any given search key. So this may sound nice, but does it really work? Actually, we still do not know how well it works. We had hoped to present first results of our annotation work at this conference, but our preparatory steps took so much longer. The big issue here is that there is no clear way of discerning good versus bad search results for a given query, which means that the notions of precision and recall are ill-defined in our case. But we still wanted to investigate the prospects of our approach, so we posed the question whether good search keys for a given word indeed would lead to this word using word embeddings and cosine similarity. But how do we define what a good search term is? We use the German Etymar in the current LEHNWORTPORTAL as a starting point for a small study. The word Riss, meaning crack or rupture, is our running example. We now look at nouns, verbs and adjectives in the word sense definitions for this etymon, assuming that they are, in many cases, semantically related to the etymon. Spalte, meaning gap, is one such word taken from a sense definition of Riss. But how can we assess whether Spalte is a good or typical search term one would use in order to find a word like Riss? In other words, how can we assess the likelihood that the term Spalte is used in semantic query where Riss is a desired result? Here, GammaNet, a WordNet type resource for German, comes to the rescue. We collect all GammaNet synsets the two words are associated with. Then we pick those two synsets, one for Riss and one for Spalte, that are maximally related according to one of the semantic relatedness measures provided with GammaNet. Of course, this introduces a certain bias into our study. We simply assume that words in the sense definition are maximally related to the words they describe. We now simply assume that a high value obtained in this step means, in typical cases that the definition term is a good search key candidate for the German etymon. Now we compute the cosine similarity of the two words, and as a final step, we see whether similarity in gammanet, that is, presumed goodness of the search key candidates, corresponds all in all to higher cosine similarity of the word vectors. Indeed, as we proceed to ever higher gammanet similarities, that means going from left to right in this graphic, the average cosine similarity increases too, up to an astonishing 0.65. Ideally, this means plausible candidates for search terms related to word X are more likely to trigger X in a semantic search based on word embeddings. The methodology of our small study is of course a lot of hand-waving, and the results are merely anecdotal. But our results suggest there is reason for hope that a future study based on usage research for the LEHNWORTPORTAL and perhaps comparing the embedding approach with a semantic fields approach might give positive results. Now, let's wrap up. What are possible benefits of our approach? Lexicographers can characterize word senses by selecting from a huge number of available descriptor words, with a word itself as a simple default. The main challenge, by the way, is that of developing an effective lexicographical process for assigning descriptor words, something that is not covered in this talk. Users enjoy straightforward usability and playful, flexible semantic access. The overall approach is very modular that every resource, in particular the whole word embedding dataset, can be exchanged for something different, easily, at any time. Thanks for bearing with us. We are looking forward to a lively discussion at eLex.